Our deep understanding of the universe did not emerge overnight. It is the product of decades of curiosity, daring, and engineering brilliance. And among the most astonishing chapters in that journey is the story of Voyager 1 and Voyager 2. These twin spacecraft, launched in 1977, were built to do something both wildly ambitious and profoundly humble: to look outward, to wander the great cosmic sea, and to send back stories of what they witnessed. Yet what makes them truly extraordinary is not only where they went, but what they became: symbols of human hope and ingenuity, and carriers of mysteries we still struggle to fully comprehend. Today, as Voyager 1 finds itself in an encounter with an unknown cosmic pressure beyond the heliosphere, we are reminded that the universe continues to surprise us, and that even our best technology must eventually face the infinite. Without these space probes, our knowledge of the cosmos, and indeed some of humanity's greatest achievements in exploration, would be incomplete. For more than 4.5 decades, Voyager 1 and Voyager 2 have continued venturing outward, braving the silent darkness and the hostile forces of deep space. These legendary craft did not simply drift. They journeyed with purpose, transforming our understanding of the solar system and what might lie beyond. It is difficult to overstate the magnitude of what they have shown us, from detailed images of Jupiter's swirling storms to the unexpected discovery of active volcanoes on Io, from revealing Neptune's violent winds to hinting at subsurface oceans on Europa that could harbor life. Each revelation was like adding a new word to the language with which we described the universe. When Voyager 1 launched in September 1977, just weeks after Voyager 2, no one could have predicted its endurance. The original plan was modest by cosmic standards: a 5-year mission to explore Jupiter and Saturn. Beyond that, engineers and scientists knew little. The spacecraft carried no modern microprocessors, no GPS, no solid-state drives, only carefully wired circuits and a few kilobytes of memory. Yet in its simplicity lay ruggedness. The probe's radioisotope thermoelectric generators provided a steady, though gradually dwindling, power supply, allowing it to continue far beyond its planned lifetime. What followed was a triumph not only of science and technology, but of human imagination. Within just a few years, Voyager 1 had already achieved feats once considered impossible. Its flybys of Jupiter in 1979 and Saturn in 1980 revealed new moons, intricate ring structures, and magnetic fields far more complex than expected. It observed the Great Red Spot in dynamic detail and sent back data that led scientists to rethink how giant planets evolve. At Saturn, it captured haunting images of Titan's thick atmosphere, sparking new theories about prebiotic chemistry that could mirror the early Earth. Originally designed to study these outer planets, Voyager 1's course eventually carried it away from the ecliptic, toward the fringes of the Sun's influence. And so began its second, unplanned mission, to become humanity's first emissary to the stars. Voyager 1 crossed the boundary of the heliosphere, the vast magnetic bubble created by the solar wind, and in 2012 officially entered interstellar space. It became the first human-made object to do so, venturing into an environment dominated not by our sun, but by the collective energies of other stars and the galaxy itself. This crossing, achieved after decades of silent travel, with a moment of profound symbolism, a message in hardware that human curiosity cannot be contained by gravity alone. Yet for all the triumphs, the journey of Voyager 1 has never been without peril and mystery. Decades after launch, its systems have aged. Its high-gain antenna, the dish it uses to whisper across billions of miles, has begun to show erratic behavior. The attitude control system, which keeps the spacecraft properly oriented, occasionally sends inconsistent data. Some scientists have even wondered if Voyager 1 might have developed a form of digital aphasia, continuing to transmit, but unable to fully articulate its internal state. And still, it speaks. Each signal, traveling over 12 billion miles, takes nearly a full day to arrive, a ghostly echo of a spacecraft built by people, many of whom have long since retired or passed away. The surprises have not stopped. Recent encounters with unexpected cosmic pressures beyond the heliopause hint that even the regions we call empty space are richer and stranger than we thought. In fact, it was the Voyager probes that first revealed that the edge of the heliosphere is not a clean boundary, but a turbulent, fluctuating zone shaped by magnetic fields and cosmic rays from distant supernovae. Such discoveries challenge our basic assumptions about how the Sun interacts with the galaxy, and, by extension, about the nature of cosmic radiation that could one day affect human explorers beyond Mars. Voyager 2, launched just days before its sibling, followed a slightly different path, one that took it past Uranus and Neptune, making it the only spacecraft to visit those distant ice giants. What it found contradicted our earlier notions. Uranus, tilted on its side, harbors complex weather systems and an unexpected magnetic field. Neptune, once thought innate, revealed fierce winds and storms more violent than any seen closer to the Sun. These encounters taught us that even in the coldest reaches of the solar system, dynamic processes sculpt planetary atmospheres and surfaces. Beyond the science, the Voyager missions hold a deeper resonance. Affixed to each probe is the Golden Record, a copper disc bearing sounds, images, and greetings in 55 languages, an attempt, however symbolic, to communicate across space and time. It includes music from Bach and Blind Willie Johnson, images of human life, mathematical diagrams, and recordings of thunder and birdsong. The idea was simple and breathtaking. If some distant intelligence were ever to find these small craft drifting in the dark, they might hear echoes of what it meant to be human at the end of the 20th century. That dream endures, even as the probes grow silent. Today, scientists at NASA's Jet Propulsion Laboratory face the increasingly difficult task of keeping Voyager 1 alive. Power levels continue to decline, and systems have been systematically toned off to preserve the core scientific instruments. By 2030, it is likely that even these will be too weak to operate, and Voyager 1 will fall silent at last. Its journey will not end, of course. Propelled by its momentum, it will continue to drift through the galaxy for millions of years, an artifact of a civilization that once dared to look outward. The challenges now confronting Voyager 1 are a testament to time itself. After more than 45 years in flight, cosmic rays have slowly degraded its circuitry, and tiny impacts from micrometeoroids have taken their toll. Communication delays, now over 22 hours each way, make real-time troubleshooting impossible. Yet the team perseveres, using ingenuity and deep knowledge of 1970s engineering to coax a little more life from the spacecraft. Each new transmission is a small miracle, and there is poetry, too, in what Voyager leaves behind. Its data have transformed planetary science, while its very existence has shaped our cultural imagination. The images it sent, of Earth as a pale blue dot, seen from the edge of the solar system, remind us of our smallness and unity. The mission's longevity has outlasted predictions by decades, and its discoveries have reshaped textbooks and fueled generations of new scientists and dreamers. Even now, the Voyagers challenge us to think bigger. The fact that these probes, with computers millions of times less powerful than a smartphone, have revealed so much about the universe is humbling. It forces us to ask, what might the next generation of explorers discover? Plans for new probes to the outer planets, to the heliopause, and beyond to the Oort cloud and interstellar medium are already being discussed. These future missions will build on the legacy of Voyager, but they will also carry a responsibility to continue the human story of exploration. What we see in Voyager 1 and Voyager 2 is more than metal and circuitry. We see the embodiment of curiosity that transcends centuries, the same curiosity that led ancient astronomers to chart the stars and Renaissance thinkers to build telescopes. We see the courage to send a machine beyond the reach of rescue, into the unknown, knowing that it might never retain data, but believing that what it might reveal was worth the risk. As Voyager 1 nears its silent future, it leaves us with new questions. What unexpected cosmic forces lie beyond the heliosphere? Could something unknown be shaping its data? And what might it yet encounter in the vast, dark ocean between the stars? These mysteries are reminders that even as our technology becomes more advanced, the universe remains larger and more mysterious than we can fully imagine. In the end, the legacy of Voyager 1 and Voyager 2 is not just scientific. It is also deeply human. It is a story about boldness, patience, and hope, about building something meant to outlast its makers. As these spacecraft glide silently through the void, they carry not only instruments and data, but our longing to understand our place in the cosmos. The message etched on their golden records may never be heard by other beings, but it speaks to us still, a reminder that we are capable of reaching outward, of asking questions that transcend generations, and of building monuments to curiosity itself. For centuries to come, Voyager 1 and Voyager 2 will drift among the stars, silent witnesses to the time when a small planet called Earth first reached beyond its own sun's embrace. Long after our cities have crumbled and our languages have changed, they will still be there, carrying whispers of who we were and what we dared to dream.